Welcome to Emmelac online tutorial, and today this is the second in series of the examples for problem solving in a uniformly accelerated motion. And today we'll be looking at this problem. Now calculate the instantaneous velocity at 7 seconds of a rocket undergoing uniformly accelerated motion if the position is given by s, which is the distance, equals 5t plus 12t squared. Now to solve this question, now you must understand now instantaneous velocity. Now here v equals to ds over dt, now which is the differential factor of the distance over the differential factor of t. All right, so this will now give us we have to differentiate this with regards to this, which means 5t plus 12t squared with respect to t. Okay, so this will now give us 5t this power 1 minus 1, then plus 12 times 2t raised power 2 minus 1. Now using differentiation, that's what we're gonna get. So v here will now be 5t raised power 0 plus 12 times 2 is 24, then t raised power 1. So we know that anything to the power of 0 is 1. So here we have that 5 plus 24, then 24t. All right, now let us input the value of t in this equation here. So here we have the 5 plus 24 times 7. Okay, so in this case here we have that the v now equals to 5 plus 24 times 7 now should give us a 168. Now 5 plus 168 will give us 173 meter per second. Now this is the answer. Very simple and concise. Like my video, share my video. All right, thank you and God bless you.